Hey everyone, in this video we're going to be talking about perpendicular bisectors and the relationships with triangles. So first, before we get into the actual lesson for today, let's refresh a couple of vocabulary terms. We talk about bisector in this lesson, and remember, to bisect something means to split into two congruent parts, or split them into equal parts, or split them into halves. Okay, so a bisector is something that does that. Perpendicular, if you'll remember, means that we have lines or line segments that are intersecting at a 90-degree angle. They're not just intersecting, they're intersecting very specifically at a 90-degree angle. That's what perpendicular means. So this perpendicular bisector looks kind of like this. So notice that we have that line C to P, okay, is intersecting this line segment A to B at a 90-degree angle. That's what that little square is telling us. It's a 90-degree angle, so that's perpendicular. We also see these little congruency marks here between AP and BP, and that's telling us that those segments are congruent. So what's happened here then is CP, that line, has crossed this line segment right down the middle. Okay, so it split that line segment from A to B into two congruent pieces. So this is a perpendicular bisector. Now, how it relates to triangles is in this perpendicular bisector theorem. Okay, so the perpendicular bisector theorem just states that if a point lies on a perpendicular bisegment or a bisector of a segment, then it's equidistant from both points. Basically, if you look at this diagram, that's telling us that if we have a point that's on our bisecting line, like this point C is on our bisecting line CP, then that point is going to be the same distance away from A as it is from B. It's the same distance from those two endpoints of the segment that's being cut into two equal parts. So we can see that these two distances then from C to B and from C to A have to be the same. So whatever one is, the other is going to be the same. Now you might also notice that when we're drawing these line segments from the endpoint to that point that's on our bisecting line, so the A to C and B to C, then we're creating two congruent triangles. And this is another way to look at this. So we have one triangle on the left that's just a mirror image of the one on the right. So all of the sides of the triangles then have to be congruent when we compare them. Now we're going to use that here in just a minute and do a couple examples, but I also want you to know that you can use this theorem, the converse of this theorem. Remember, the converse statement just takes those if and then parts, the hypothesis and conclusion, and switches the order around. So we can take that and create a converse statement, and we can use the converse statement then to prove that we have a point that's on a perpendicular bisector. Because if for instance in our diagram here on the bottom right, you notice that D is the same distance away from A as it is from B. That's what those little congruency marks are telling us. And so if that's the case, then point D has to be on a perpendicular bisecting line. Okay, so that's all that this means. So if we see this, something like this, and we're trying to prove that this line from CP is a perpendicular bisector, we can do that because D is the same distance away from the two endpoints. Now let's do a couple examples here. So here is a diagram that you're going to see. You're going to see something similar to this, and we got to pick out a couple of things from this diagram to know that this is a perpendicular bisector. Remember these congruency marks? That's telling us that the distance from P to Q and Q to R are the same, that they're congruent. So that means that SQ, that line, is bisecting that segment from P to R. So it's splitting it into two congruent pieces. We also see that 90-degree angle right there, so Q to S is not only a bisector, but it is perpendicular to that line segment P to R. So this is a perpendicular bisector, and if that's the case, when we have this point S that's on that perpendicular bisector, then that has to be the same distance away from R as it is from P. And so you'll notice in the two triangles then that we've created here, that RS or that RQS triangle and the PQS triangle, we have the hypotenuse of those two, SP and SR, that are going to be the same. So if SP is 6 to 8, then SR has to be 6.8 as well. We have another example right here where we're trying to find the distance from E to G. Now again, if we look at this as we have two congruent triangles, we know that because E to H and G to H are the same distance away. So this line coming down from F to H has to be a perpendicular bisector. You can see the 90-degree angle, it's perpendicular. We know that that has to be a bisector then because point H is the same distance away from G as it is from E. And so then the E to F distance will be the same as it is on the other side from F to G. So if F to G is 9.5, E to F is 9.5. And then to find EG, remember we just add those two pieces together, and that would give us a total distance of 19. Now let's put a little bit of algebra into this, just to make it a little more challenging. Again, so we know that this line segment, or this line from B to D, is a perpendicular bisector. It looks just like the ones we just did. So we know that we've got two congruent triangles that are on either side of that bisecting line. Or we can say that D is the same distance from C as it is from A, because D is on that bisecting line, that perpendicular bisector. So if we know that CD and AD then are going to be the same, then we set up an equation where they're both equal to each other. So 3x plus 14 represents the same amount as 5x, so we just create an equation where those amounts are equal to each other. And then you solve for x. Again, take away the x from both sides, and then we divide. X is 7, and then to find the distance from AD or CD, all we have to do is plug in that x value of 7 into both of those expressions. So A to D is 5x, which is 5 times 7, which is 35. C to D is 3 times 7 plus 14, which would also be 35. So these are the perpendicular bisectors. And again, you're creating two congruent triangles that are mirror images of each other. That's one good way to look at this. That's all we have for this one. Stay tuned for the next video where we cover angle bisectors and those distances.